Hi everyone, I'm Dr. Kiran Raavi, working as Assistant Professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. So today we are going to discuss applications of Zener diode. So the overview of today's presentation start with introduction. So what is the special purpose diodes, and then we discuss Zener diode and construction and operation characteristics, and particularly applications of Zener diode as a voltage regulator. So applications of Zener diode. So voltage regulation. Zener diodes can regulate voltage in a circuit by shunting excess current to the ground. So this is very useful concept, useful process of Zener diode. This is the best advantage of Zener diode. So they can regulate the voltage in a circuit by shunting excess current to the ground, because Zener diode, the basic function of Zener diode is it maintains constant output. So whatever the input voltage, so if there is any increase in the input voltage, it does not allow, because the current ground reaches to zero. Excess current, if there is any excess current is there, so that comes to ground. So that is the basic concept of Zener diode. So this can be utilized for regulation of voltages. Voltage reference. So it can also be used as voltage reference. Zener diodes can provide a stable voltage reference for other circuits. So in some integrated circuits, you can different kinds of circuits are there. So for specific application, specific circuits are designed. So they must be integrated. So in such case, so we have to refer the particular voltage, circuit voltage. So in such case, we can use this Zener diodes. Next, over voltage protection. So because the Zener diode maintains constant output, so if there is any excess voltage is there, so that will block by the Zener diode. So Zener diodes can protect the sensitive components from damage caused by over voltage. So if there is any over voltage, usually our domestic purpose, so we are getting 230 volts. From that 230 volts, you have to utilize properly for specific gadgets, particularly DC gadgets, DC operating gadgets. So if the required voltage is greater than the reference or threshold voltage, then obviously your gadget may gets damaged. So in such case, to avoid this kind of situations, we require Zener diodes. So Zener diodes can be used in over voltage protection. Now signal conditioning. So these kind of Zener diodes can be used in signal conditioning, because they can clip or clamp signals to a desired level. So this is also one of the important applications of Zener diode in signal conditioning, because so few circuits required few voltages, so specific voltage. Even though those circuits are integrated together, so particular circuit required, suppose amplification circuit, then rectifier circuit, and then you can have clipper circuit, clamper circuits. So in such case, so depending upon the application, so we require all these, and so total board required, some actual voltage is 230 volts for example, so that will be stepped down so into the lower voltages, and that lower voltage is given to the all the individual circuits in the integrated circuit. So in such case, you can have a signal has to be conditioned. So Zener diodes can clip or clamp. So what do you mean by clip and clamp? Clipper means, so it has some part of the data can be clipped. So I want this one. So this much is required. So in such case, I can use clipper circuits. Okay. Suppose clamper means, this is regarding clipper. The clamper means adding DC voltage. So this is actual voltage. So after applying some clamper circuit, so clamper means adding DC voltage. So this reference voltage changes to some voltage, either positive side or negative side. So In such case, signal conditioning can be done using this Zener diodes. And then other application is surge suppressors. These are can be applied used in Zener diodes can be used in power strips to suppress the surges. Okay, so there is a delay. There is some delay in the signal conditioning. So from may reach after some time. So and also surges takes place. So in such case, we can use Zener diodes. Zener diodes are very effective in surge suppressors. And then low noise levels. So Zener diodes are beneficial in applications that demand a low noise level, because Zener diode generates very less noise compared to other components. So like sensitive electronic equipment or communication systems. So in communication system, noise play major role, because so noise added. So for example, if you take the amplifier, so if now noise increases in the communication system, obviously the amplified signal gain will be reduced. So that is the drawback with the communication system. So in some communication system, noise must be reduced. So in low noise level applications, Zener diodes are very beneficial. So because electronic components are very sensitive components, because they change their properties with the environmental changes. So that is introduction applications of Zener diode. So today we mainly focus on voltage regulation. So Zener diodes are very useful as voltage regulators. So this is the appearance of the Zener diode symbol, and this is the schematic symbol. So breakdown current flow to, but only pass the Zener breakdown voltage. So this is the direction of flow. So a voltage regulator is a device that regulates the voltage level. What do you mean by voltage regulator? It maintains constant voltage level. Voltage regulators are used in computers, power generators and alternators to control the output of the plant. So otherwise, so if the more voltage generated from the input side, so beyond, if it crosses the beyond level or threshold level, then obviously your output gadget or whatever the load change may damage. So in such case, we have to maintain some constant voltage. A semiconductor diode blocks current in the reverse direction, but will suffer damage if the reverse voltage applied across the becomes too high. So that is the advantage of this Zener diode. How Zener diode can act as a voltage regulator. So a semiconductor diode blocks current in the reverse direction, but will suffer damage if the reverse voltage applied across the becomes too high. Because if you apply more reverse bias voltage, then obviously your diode gets, normal PN junction diode gets reverse bias. But whereas Zener diodes, they are specially designed to operate in reverse bias condition. So how it acts as a voltage regulation. Zener diodes can regulate voltage in a circuit by shunting excess current to the ground. So shunting means it's so across the Zener. So Zener diode. So you can say circuit diagram. So let me write here. So you will have series resistor here, and across this you will have Zener diode, and here you will have some load resistor, and across this you will measure output voltage, and here you are giving input voltage Vs. So here Rs means series resistor, so or you can say source resistor, or you can say current limiting resistor particularly. So current will flow like this. So across this we say Vz, Zener voltage. So here V0 is approximately equal to Vz only. So whatever the input voltage you are giving, so the output voltage is maintaining constant. Whatever the voltage you are giving, the output voltage becomes the voltage across the Zener diode voltage. So whatever the voltage available across the Zener diode, that will be the output voltage. So it is essentially steps down the input voltage to the desired level and keeps it at that same level during the supply. So this ensures the This ensures that even when a load is applied, the voltage does not drop. That is the advantage of this kind of voltage regulator by the Zener diode. So this is the actual circuit of the voltage regulator, Zener voltage regulator. So this is Zener diode, and here load resistor is there. So there is a series resistor connected to the circuit to limit the current into the load. It is connected to the positive terminal of the DC. It works in reach in such a way that reverse bias can also work in breakdown condition. This we have already discussed previously. So do not use any ordinary junction because at lower rating diode can get damaged when apply reverse bias above the breakdown voltage. So up to certain voltage, okay, in normal PN junction diode, so we can give normal reverse bias voltage up to certain. So after threshold or after breakdown voltage, the diode may get damaged. So when the minimum input voltage and maximum load current are applied, Zener diode current should always be the minimum. So that is the advantage. Since the input voltage and the required output voltage are known, it is easier to choose a Zener diode with a voltage approximately equal to the load. So that's why whatever the voltage we have, load voltage is approximately equal to Zener voltage only. The value of the series resistor is given by Rs is equals to load voltage minus Zener voltage upon load current. Okay. So therefore, current through the diode increases when the voltage across the diode tends to increase, which results in the voltage drop across the resistor. So if voltage drop across this resistor increases, means the current is decreasing. So current through the diode increases when the voltage drop across tends to increase. So here, because the current flowing to the, so when we apply any unregulated voltage VL, so therefore, so there is a current flow through the source resistor or current limiting resistor. So when current increases, the drop across the source resistor also increases, which results in the voltage drop across the resistor, right? So therefore, because of this, so it can maintain constant DC output voltage. So therefore, that means the output voltage is regulated using this Zener diode. Okay, so this is the basic view of Zener diode as a voltage regulator. So let us summarize what we have learned today. So we have started with the introduction to the Zener diode, and we have discussed what are the different Zener diode applications, Zener diode construction and operation. So after that we have discussed the construction and operation, and then characteristics now. So we have discussed the applications, particularly applications is voltage regulator. Zener as a voltage regulator. So whatever the voltage we are giving at the input side, so that means sometimes the input voltage may increase. There may be a chance of fluctuating the input voltage. In such case, for example, we have a circuit like this. So this is your Zener diode, and here load resistor. Load resistor means it may be let us say bulb. You can take, so bulb has some resistance, so minimum resistance is there. So threshold value we have to maintain. So in order to maintain that threshold value, if your input is, for example, if your input is beyond that threshold voltage or level, then obviously if there is no Zener protection, then obviously your diode, or we can say the output gadget or whatever the equipment, whatever the component device we are inserting at the output end, then it will get damaged. So to avoid that, so we require some protection that can be done by your Zener diode. So that's all for today. Thank you.